This is ACT prep. We have number 7. The number of fish, F, in Skipper's Pond at the beginning of each year is modeled by the equation f of x equals 3 times 2 to the x. So it's 2 to the xth power, where x represents the number of years after the beginning of the year 2000. So for example, x equals 0 is the beginning of the year 2000, x equals 1 is 2001, and so forth. So x equals 2 would be 2002. So according to the model, how many fish were in Skipper's Pond at the beginning of the year 2006? So this question, all it is just figuring out, do you know how to use this equation? So remember, anytime we have f of x is just kind of like saying y, okay? The reason we use f of x, the advantage, is we can write f of, so I'll copy our equation first. We have f of x equals 3 times 2 to the xth power, okay? If we have f of 0, like if we substitute, just like we substitute on our right side, like for y equals, if we substitute the x for 0, it's showing we can do the same thing over here. So it's a little visual way of showing it. And we know that when x is 0, we have the beginning of the year 2000. Okay? So you could solve that. You could find the base number. So for example, 2 to the 0 power is 1, times 3 is 3, f of 0 is 3. But it doesn't want to know that. It wants to know how many fish are in Skipper's Pond at the beginning of the year 2006. Luckily, that's exactly what our equation gives us. Beginning of each year, and then can be modeled by the equation. Can be modeled by the equation just means when you plug in x for your value, you'll get this result. Okay, the result before the can be modeled by. So in this case, it's the beginning of each year in fish. As I drop my pencil, everything's going everywhere. So then we do f of, instead of 0, we do f of 6 because 2006 is 6 years after 2000. So 2006 minus 2000, that's 6, f of 6. It's kind of a straight line. We want a curved line for our bracket. Okay, f of 6 then equals 3, and then just direct substituting, times 2 to the 6th power. Okay? Okay, and then we can simplify this. Might be a little more than that. If you can't do this in your head, because it's 2 to the 6th power, that's a high power, a trick is we can use our exponent rules to simplify it into 2 to the 3rd power times 2 to the 3rd power. Okay, because we know that we can split this into 3 plus 3. So that's a great useful exponent rule. Anytime we have, for example, if we have these exponents here, it's easier to go in reverse, right? So if we have these exponents here, and they're multiplied together by the same base, we can add the exponents to get 2 to the 6th power. So another example would be like 2 to the 7th power equals 2 to the 3rd power times 2 to the 4th power, because they have the same base, and 3 plus 4 equals 7. You could also have 3 to the 4th power, and that would equal 3 to the 3rd power times 3 to the 1st power. If you don't believe me, try it for yourself. Again, 3 plus 1 is 4. So that's one of our exponent rules that we can use. And we know 2 to the 3rd power is just 2 times 2 times 2. And that's easy because 2 times 2 is 4, and 4 times 2 is 8. So this equals 3, 2 to the 3rd power, 8, because 2 times 2 is 8. 4 times 2 is 8. And we already did 2 to the 3rd power for the first one, so that's also 8. And we know 8 times 8, so 3 times 8 times 8, which is 64. And 3 times 64 might be a little harder to do in your head. But you could use a trick where you do 3 times 6 to get 180, plus 3 times 4, which is 12, which is kind of just like our long division, just like in a horizontal form, or our long multiplication in horizontal form. And 180 plus 12 is 196. So our answer, 192, excuse me. Again, even teachers make mistakes. Mistakes are a good thing to make. Everyone thinks mistakes are a bad thing. Mistakes show that you're learning. Mistakes show that you know how to do the process fully, because you don't learn anything from doing it correctly in the first try. You learn things from making mistakes. So our answer is 192, which is B. Our answer is B.